Ladies and gentlemen, welcome to the Geological Society of London and to this, the second Society London lecture for 2014, entitled Oil and Gas Exploration in the Arctic. My name is David Shilston and I'm President of the Society. It's my special pleasure to introduce today's speaker, Professor Al Fraser of Imperial College here in London, who just happens to be our Science Secretary. In the past 3 decades, 200 billion barrels of oil have been discovered under the Arctic. There may be as much as 114 billion barrels of undiscovered oil and 2,000 trillion cubic feet of gas there as well. That's possibly more than a fifth of the world's undiscovered reserves. And in a world of diminishing resources, this is a great and irresistible prize. This region, where ice is present for more than half the year, brings considerable technical challenges to oil companies, with the ever-present threat of causing damage to a pristine environment. At a time when the world is being encouraged to kick the carbon habit, exploration in the Arctic will be fraught not only with technical, but environmental and political challenges for years to come. Our speaker this afternoon, tonight, misread my notes. Our speaker tonight, Alastair Fraser, is EGI Professor of Petroleum Geoscience at Imperial College in London. Al previously worked for BP as a petroleum geologist and exploration manager for over 30 years. He has written many papers on petroleum geology of extensional basins, most notably the North Sea Jurassic and Northern England Carboniferous. Ladies and gentlemen, please welcome Professor Fraser.
Thank you, David. Thank you very much, everybody. I'll just give David his speech back. It's obviously what he'll want to keep.
Have you signed up?
Of course. Good evening, everybody. Thanks for coming along to the Society. It's great to see the lecture theatre so full. And you're probably wondering, what are my credentials for talking to you about the Arctic? Well, Scotland does get a little bit cold occasionally, but it's certainly not north of the Arctic Circle. Well, when I started my career in BP back in the late 70s, the first posting I got out of the North Sea was to Anchorage in Alaska and to work on the North Slope. And I arrived there in January of 1979. There was no daylight, a twilight at best at that time. And here was this wonderful, pristine wilderness, and I was being asked to help drill this well out in the Beaufort Sea. It was fantastic. And despite many visits to Aberdeen, I have never seen northern lights like you get in Alaska. So I kind of fell in love with it. And throughout my career, I've always sort of ventured back to the north, and either as an explorer, geologist, or in development. And it's continued to fascinate me. I might have started in Alaska, but I've had the fortune to work in the Russian Arctic and the Norwegian Arctic as well. So I can hopefully talk to you a little bit about that. So I have some experience in the Arctic. By no means an expert of everything to do with the Arctic, but hopefully I can give you today a feel for a few things associated with the Arctic. Not just the geology, and we will talk about Arctic geology since this is the Geological Society, and it's important that we do try and understand the geology of the Arctic if we're going to understand that first point, which is the resources. What's all the fuss about? Why are all these oil companies spending billions of dollars accessing acreage in the Arctic? Is it there? We'll talk a little bit about the Arctic geology. There's not a lot of data that covers the circumarctic. If you look at the Arctic north of the Arctic Circle, across the Arctic is 5,000 kilometres. It's a large area, and I'll show you some maps of it a little later. Now, like any frontier basin, it's a classic case of the geologists see the potential for oil and gas, and the technology, the poor engineers have got to follow. It was like this in the North Sea when I started my career. We found the oil and gas, and the engineers had to work out ways of getting it ashore from up to 200 metres of water. It's the same with the Arctic. We still haven't got any technologies capable of producing from under ice sheets that are moving at up to 3 metres an hour in shelves that contain up to 200 metres of water. We just don't know how to do it yet. And then finally, it's important to address the socio-political aspects. It's very different, the Arctic, to a lot of other places we go in frontier basins. Lots of interests. 5 different countries that are regulating the Arctic. Indigenous peoples. There's more than 4 million people live and work in the Arctic, but 15% of them are indigenous peoples who hunt, live, fish in the area. And then there's governments who have different views on how fast Arctic exploration production should take place. So we'll look at that as well. So it's not just getting a lot of geology maps out and seismic cross-sections and trying to understand what the next prospect is to drill. It's much more complicated than that. In fact, if all I leave you today with is the message that the geology's fine, it's the technology, the environment, and the politics and the people that are the problem. Or, not the problem, but the issue. So, lots going on. I just pick up. I'm still allowed to read the Financial Times at Imperial. That's one thing they do concede me. And every one I pick up, somebody's got a new license in the Arctic. I'm not going to go through this whole slide, but there's a few things we need to pick up. There's lots of big numbers on here. People are spending a lot of money. Shell, Juche Sea, there's $6 billion of their shareholders' money has already been sunk into that area. And there's not a single well drilled since they got their new licenses. So this is expensive and difficult. The East Greenland license rounds have been announced. You'll recognise some of the companies, including my old firm, Eni, BP, Dong, Chevron, Shell, Statoil, ConocoPhillips. That's off East Greenland. I can't think of a worse place in the world to go exploring. It's probably, from a climate and environment point of view, the most difficult place to put anything made of steel, because it's going to get knocked down by icebergs, moving ice shelving, large, sort of building-sized pieces of ice that are just thrown by the sea at your infrastructure. It'll soon knock platforms down. So it's very, very difficult. And then this one, I picked up my oil and gas journal last year to find out that Exxon had been extremely busy in the East Siberia, Laptev Sea and Kara Seas off northern Russia. Great places to go. But that's got ice 6 months of the year, and there is no way at the moment they know how to produce anything they find. So, lots happening, lots of money being spent. Why? Why are people going there? There we are. Right, let's step back. What I'm going to show you, when I talk about the Arctic, I don't use equatorial projections, because it just makes Greenland look enormous and you don't get a feel for the real scale of the Arctic. We'll use polar projections, so they'll have the North Pole at its centre. And this is what the Arctic looks like about this time of year. The maximum extent of ice. And as you can see, it's pretty much 100% socked in by ice. The only place that's not is the Barents Sea. And that's why the Russians have their submarine and naval bases at Murmansk and Archangel. It really is ice-free year-round. And actually exploring in the Barents Sea is no more difficult than what we're doing in the North Sea present day. So that can be done. And that's kept warm by the Gulf Stream. But the rest of it is completely ice-bound at this time of year. So this makes the point about the Arctic being an ocean surrounded by continents, which is different from the Antarctic, which, when you think about it, is a continent surrounded by a large ocean. Now, that difference is important because when you've got an ocean surrounded by the continents, people live here because they've marched north. And so you have to deal with indigenous populations. So let's take the ice off. I still use this diagram because I remember it as a boy in National Geographic. They produced these maps that showed what the oceans look like. I remember almost my first interest in geology actually stemmed from this type of image. And you can see the Arctic Ocean. There's Alaska here, Juche Sea, Greenland, the Sverdrup, the Barents Sea, Kara Sea, northern Russia, the two big deltas, the Lena Delta, that's it shown on that picture on the wall over there, this beautiful glacial delta, and then the other deltas down here, which is the Mackenzie Delta. So these are the main deltas that come into the Arctic. It comes in here, the Mackenzie. The first thing that strikes you about this is the Arctic's not just a big ocean. It's actually mostly 50% continental shelf, and large continental shelves. These are continental shelves we rarely see anywhere else on the planet. The Barents Sea, the Kara Sea, the East Siberian Platform, and the Laptev Sea. These are massive shelf areas, and we like continental shelves as petroleum geologists because continental shelves contain basins, and basins contain the building blocks of oil and gas plays. Reservoirs, sources, seals, traps. So these areas here are pretty important in terms of finding oil and gas. They're also major passive margins, the like of which works around the South Atlantic, Gulf of Mexico, off India. All over the world, these are good places to look for oil and gas. And here they are. From the Kara Sea, right round to the Chukchi Sea, 5,000 kilometers, there is not a single well drilled for oil and gas. This is really unexplored frontier, and very little seismic data. It's just beginning to appear now. Now, on the basis of looking at this map, and who owns the continental shelves, and therefore possibly most of the oil and gas, it's quite clear who's the winner here. It's Mr. Putin. He owns all this. So probably 3/4 of the oil and gas that's going to be found in the Arctic is going to be in Russia. Just a fact, just from the geology. You could see by comparison the continental shelves off Alaska, Sverdrup Basin and northern Greenland are really quite narrow. So it's quite different. I shouldn't put the slide away until I've mentioned what this is. This is, I guess, Iceland. So this is the North Atlantic Ridge, and it comes ashore here. It actually tips out in eastern Siberia, and that's where the Lena Delta comes out. And then there's another oceanic basin here, the Canada Basin. It's a little older. It tips out here, and that's where the Mackenzie Delta is. So you see, geology's pretty lazy, really, isn't it? The deltas come in where they see the tip out of the spreading ridges and just come into the basin. And these are the only two major delta systems in the Arctic. While we've got this up, there are 5 countries that kind of are heavily involved in regulating and licensing Arctic exploration and production. The United States through Alaska, Canada, Sverdrup, Denmark via Greenland, more on that later, Norway, and then the former Soviet Union, Russia. So these are the 5, the Arctic 5, who ultimately will produce, hopefully, a consistent regulatory framework for this activity. There we go. Now, my students, when I talk about Arctic exploration, quite rightly say, well, why do we have to go to the Arctic, Al? We've got lots of oil and gas on the planet, haven't we? We don't need any more. And if I was a visitor from outer space, I would probably ask the same question. There is lots of oil and gas on the planet. Problem is it's unevenly distributed. Most of the remaining oil and gas sits in the Middle East. The use of that oil and gas is in North America, Europe, and the Far East. It's not the same place. There is a security of supply issue here. Getting it from the Middle East to where it's the markets where it's actually used, these freight routes or these routes, transport routes, can be easily disrupted. So the international oil companies are looking seriously at alternatives, and countries are looking at alternatives. So that's why it doesn't quite work, because we can't get the politics right across the globe and share the stuff. The other problem is we are hooked on oil and gas as a world population. Here's the fact. This is from the BP Energy Outlook from 2011. There are lots of others of these which are very similar. This is today, that white line there. Black is coal, green is oil, red is gas. That's the energy use on the planet at the moment. It's about 1/3 coal, 1/3 oil, 1/3 gas. And 10% is renewables, including nuclear and hydro and the wind, solar, and waste burning activities. Now, these are the fastest growing, the renewables, but they're coming from such a small start. It's going to take a while to get these to take on a really important part of this graph. Over the last 20 years, on this planet, we use 45% more energy. Just over 20 years. And if you believe this graph, over the next 20 years, it's 40%. So we're still going to be requiring a lot of energy. And it's the resources of the Arctic are part of the bridge that's going to get us to the next energy source. So we'll look at numbers a little later, but it's probably about 30 years for the planet at current energy use rates. Now, and when we look at the amount of oil and gas that might remain to be discovered, there's probably going to be round about, these are big numbers, according to the USGS, 114 billion barrels of oil. David's already mentioned this, 2,000 trillion cubic feet of gas, and some natural gas liquids. Now, the USGS, the United States Geological Survey, did this study. It's largely a statistics-based study. There's not a great deal of geology involved in getting these numbers, but it's a good start. It's given us all something to start with, to examine, and to challenge. And you can probably see by this, gas is their favoured resource for the Arctic. They think the Arctic's going to be gassy. I disagree. The Arctic, as I hope to show you, is full of world-class oil-prone source rocks that will sit in the oil window. So that's the piece that the USGS have not taken into account. There we go. Now, the USGS kindly produced some very nice diagrams for us. Just let me translate these for you. If it's really dark green, they think there's lots of oil to be found. These are billion barrel provinces. If it's lighter green, a little bit of oil to be found, but there'll be some. And if it's white, well, we don't think there's anything. They base these on assessment areas. So this is their diagram for oil. So, yeah, that's okay. Lots of Alaska, the Beaufort Sea, that's okay. They will still find oil and gas there. This is East Greenland. Oh, the new seismic shows this is completely wrong. There is a well-developed Jurassic system there. That will have more oil and gas than that. This is a little bit optimistic. There's probably not a regional source rock over there. This is completely wrong. This is the South Kara Sea. When I was working on the Arctic in industry, this was my favourite piece of the planet. If we were going to find lots of big oil and gas fields in future, it was going to be in the South Kara Seas, just north of Western Siberia in Russia. And I'll show you why. I'll show you some diagrams later on, hopefully that will support that assertion. I think, yeah, that's okay for the balance. Maybe there should be a bit more. And there certainly should be more out here. There's some very good source rock potential and reservoir potential in eastern Siberia. And this is the area that Rosneft and ExxonMobil have licensed. So that's the oil picture, according to the USGS. Let's have a look at the gas. So they think the South Kara Sea is gas prone. Disagree completely. Some simple geochemical modelling shows that that main source rock is in the oil window. That's fine. Yeah, I agree. The Triassic and the Barents Sea, Eastern Barents, probably a lot of gas from here. And again, there should be a lot more gas up here in East Siberia. But as I say, it's a start. But once you start applying geology to the Arctic, I think you get a different answer than what the USGS got. Right, so as I said, all my maps are going to be based on polar projections. So I went looking for what were the first polar projections of the Arctic. This is pretty good. This is Mercator, who drew this in 1595. This isn't bad, guys. 1595? Well, look, you can see there's Alaska. There's the coastline of Norway, Iceland. All right, I agree. Novaya Zemlya could have been better. And that's a pretty bad attempt at Greenland. Must have been a Friday map, that. And, you know, he didn't know, but clearly in the Arctic, there is no continent. This is called Crocker Land. And I'm afraid Crocker Land doesn't exist if people were thinking of exploring here. That is where the Arctic Ocean really is. But otherwise, pretty good attempt. Let's have a look at some of the early explorers. Nansen, a Norwegian, was probably the first person to make his name exploring the Arctic. He was certainly the first person to cross Greenland by sled. And his ship, the Fram, they had a 3-year expedition to try and reach the geographical North Pole. He didn't get there, but he certainly set a record for the time at 86 degrees 14 minutes in April 1895. It's a tricky time getting out, and he came out via Svalbard and Spitsbergen, but he was the first one to really get pretty far north. But who was the first person to really get to the geographical North Pole? Well, it is now pretty well agreed it was Robert Peary back in 1909. He's an American naval engineer. And he made one fatal error in getting to the North Pole, the geographical North Pole, which none of us would make now. He didn't take a navigator with him. So it's kind of important to be able to establish that you actually got there, and he really wasn't able to do that. And his claim was poo-pooed for almost a century, mostly by the British, by the way, until a British explorer, Tom Avery, in 2005, actually did what Peary did with the same equipment in the time he took, and is pretty convinced it was doable. So it looks like Peary probably got there and has claimed the surface of the North Pole for the Americans, if we're back to 15th century flag planting as a way of establishing ownership of continents. More later on what the Russian answer to that was. I put this up just to, really as a refresher. I'm not going to spend a long time on it because I talked about the Arctic 5 and the marine, the oceanic versus the shelves on the National Geographic map. But these are the oceanic crustal areas. One thing I should have pointed out was the Lomonosov Ridge. This is going to play an increasingly important part of who owns the Arctic in future. It is demonstrably a piece of continent that split off from Eurasia during the opening of the North Atlantic and Eurasian Basin, sometime in the Eocene. So there's this very thin sliver of continent. The North Pole, as you can see, sits here. So does it belong to Greenland, Canada, or Russia? All countries are spending quite a lot of money to try and back up their claims at the moment. It's great, it's bringing money into universities, sampling's going on, we're getting to do research on the basis of it. But these are the key areas in the Arctic. So my history in the Arctic is, as I said, it's quite a long one. This is the early days of fieldwork in the Arctic of Canada and America. This is up in the Brooks Range. This is BP chief geologist. He wasn't at the time, David Jenkins, some of you might know. He's still very active in the society. And he was in one of the first field trips to the area. This was the rig I worked on. You can see the amount of energy that's being used just to actually drill a well out on the ice. Look at the beautiful, pristine Trans-Alaska pipeline. This was 1979. It had just been built and opened. Now, 30 odd years later, it's not in quite such good condition. These things are beginning to, outlive their useful life. We were shooting seismic up there on the ice, getting data, and this was Petroleum's answer to drilling offshore in the Arctic. They used drill ships that were actually icebreakers and were followed by icebreakers. So it can be done. Even when I joined the industry in the late 70s, people were exploring offshore in the Arctic. It's a harsh environment. I mean, this photograph was taken, I think it was minus 40 degrees. But it's not all bad news. Here's the ice summary for sometime in September. I think it was September 2011. And you'll see that the picture is very different from what I showed earlier on. Vast tracts of the Arctic are beginning to open up in the summer, in September, to navigation and operations. Isn't this a horrible paradox, folks? The industry that produced most of the carbon that's in the atmosphere, that's warming it up. The Arctic's probably warmed about 3 or 4 degrees over the last 50 years. is now in a position to take advantage of the melting ice for their own operations. I can see the headlines now, but that's where we are, unfortunately. Of course, this retreat of the Arctic ice in the summer has been taken advantage of by the Russians, and they are proposing a Asia to Europe sea route through here, which is a reality. It will happen. Takes the Suez Canal right out of the picture. What else can we say about here? I think, from what I've seen in the progression, on the projections, 10, 20 years' time, all we'll see in the summer is this last piece of ice here. So the North Pole will finally become exposed to the satellites. There will be no ice on it in the summer. That's quite a, as something it's not going to make a great deal of difference in terms of global warming and sea level rise, but it will have a dramatic impact, I think, on the planet. And what's happening is, it's because we're warming the Arctic, we're melting the ice. We're melting the ice so there's less reflection of the sunlight. The seawater absorbs the heat, more ice melts. It's kind of a vicious circle that we're in. So it's not very far away that day now when that's the last piece of ice we'll have left. Anyway, back to the winter. It's not much good. Sorry, this shouldn't be moving on. There we go. There we are. Right. This is the winter ice. And you can see it's changed completely. I showed this earlier. Any navigation up through the Northwest Shelf becomes very difficult. The Northwest Passage becomes very difficult. Exxon tried it with the USS Manhattan in 1969 and just got stuck. After Prudhoe was found, this was going to be the exit route for the oil and gas. This is why the pipeline was built from Prudhoe to Valdez, the ice-free port in the south. Here's the ice rotating, probably clockwise, and probably up to about 3 meters an hour. That's a lot. You know, if you put something down here, a facility, a rig, you know, come back the next day and it's 70 odd meters away. So putting infrastructure on top of the ice isn't going to work. Now, when I was working up in Alaska, what we did was we built artificial islands. It was offshore, the water was about 50 meters deep. You can do that. But to get at this part of eastern Siberia, it's much deeper than that, 50 to 200 meters deep. You can't just go and build an artificial island. You have to take the ice out of the equation. And you really do, because this is nasty stuff once it gets going. As the poor old Titanic found out to its cost, in April 1912, berg that came out through the Labrador Sea was responsible for the sinking of the Leviathan, the ship. So these are problems. Here's the East Greenland part here. There's also a lot of bergs come out through here. So it's a problem. The ice is really, as I say, it's not the geology it's the problem, it's the environment and the politics. So let's get on to the geology and the resources. The first thing I can say to you is that quite a lot has already been found. In two small areas which have received most of the drilling. Up here in Alaska, where I was working in Prudhoe Bay, and in the onshore part of Western Siberia. So this is, Urengoy is here, which is the major gas collection facility for West Siberian gas from Russia into Western Europe. And the Kara Sea is the extension of this province once we start getting back into the oil window for the source rocks. So you can see here, if you add Russia up, 87, 21, 22, we're well over 100 billion barrels of oil. So almost 2/3 of the oil already found in the Arctic is in Russia. And that trend is going to continue. What I'd like to do, if this works properly, is toggle between this and where the wells are, i.e. the wells that we're looking for oil and gas. There they are in yellow. You see they're distributed around here in the Barents Sea in Norway, a little bit here in the Russian Barents, nothing for 500 kilometers through here, and then the wells in the Mackenzie Delta and offshore Alaska. Vast tracts, unexplored completely, all continental shelf. So that is what the industry is looking at in terms of future potential. So if we go back, you'll see where people have drilled, they have found oil and gas. And that trend is going to continue as people extend that drilling beyond where it's already taken place. Right, let's have a look at the geology. You've really got to start with the only regional data set that's available to us at the moment, and that is gravity and magnetics. This is gravity. It's from the Arctic Gravity Project. There are other more detailed gravity data sets out there, but this will do okay for just this exercise. What you can see in here, I've put the present day outlines of the coastlines on here, and you can see the North Atlantic Ridge through the Eurasia Basin, and here's the Lena Delta. So that is that spreading center, an oceanic basin. Here's the Lomonosov Ridge, there's the North Pole, geographical North Pole, and here's the Canada Basin. Quite difficult to see the Canada Basin, but there is a ridge that runs through here. Now let's put some geology on if we can. Right, so there's the tertiary spreading oceanic crust of the North Atlantic and the Eurasian Basin. So we won't be going to look for oil and gas there. That's oceanic crust. Let's look at, there's the Baffin Bay and Labrador Sea. That's probably oceanic crust again of tertiary age. So that sits between Greenland and Baffin Island. The Amarasia Basin. This is a bit older. This is Cretaceous in age. And I'll show you a bit of seismic later that shows how this basin formed and how Prudhoe Bay actually just sits off in here. So you'll see that right at the edge of that basin. So these are the two main oceanic basins. Now we're having quite a bit of a debate in the academic world at the moment as to what happens in here. I've been doing some discussions with Shell, and we've kind of decided that that ridge comes all the way to the Lomonosov Ridge, and this is just one big oceanic basin. It's kind of opened like a great big windscreen wiper. It's moved this large piece of continental crust away from northern Canada. So it's opened like that. And in here, there's a lot of igneous rocks, igneous material, a large igneous province that is kind of hiding that ridge from us. And I presented this in Canada a few weeks ago when I was over. And they came up to me and said, well, listen, actually, we've got some new data we haven't published yet, but we've got ages for these volcanics. And they're not tertiary, as you suggested, or Shell suggested. They are actually Cretaceous. So we're kind of back to the old model, which is a little bit messy. It's not perfect. It's a series of fragmented spreading centers with quite a lot of volcanic activity around about. That still has to be sorted out. That clearly still isn't correct. So a little bit of work to do before we get this fixed in that place. It's not really of that much importance for oil and gas, but in terms of understanding the opening of the Arctic Ocean, it's pretty critical. And as to who owns the Lomonosov Ridge and therefore can extend their area of influence beyond the 200-kilometer limit, it's even more important. So there's our oceanic crust. So we're going to try and build a treasure map now. Where are we going to go and look for oil and gas? Where's it going to be found if it's there? Well, first of all, let's put the passive margins on. So these are areas adjacent to the oceanic crust, normally highly rifted. In this case, probably not a lot of volcanic material, so there'll be non-magmatic margins. And they probably contain some really good sediments and basins. And we know they do. We can see from the few bits of seismic data we have. Really poorly explored, apart from the Norwegian Barents here. This is about to be explored, and there's a few wells drilled by Cairn off Disco Island here. There's some wells in Sverdrup here, but this whole piece here is completely untouched, and there is part of the South Kara Sea. Let's continue on. Here's the continental extensional rift basins that sit behind these passive margins in blue. This is where the oil and gas has been found to date and will continue to be found. So these are Mesozoic basins, what I want to suggest, with some world-class source rocks within them and a lot of potential going forward. So this is, you can see these taken the the Kara Sea here. This is Elaptive. Here's East Siberia. And then this is the piece that's already working in Sverdrup. So these are the extensional basins that surround the Arctic. And all of them got a little bit of compression, just to form some nice, gentle, but large folds. So quite like the Middle East, I think these are going to have some very significant traps within them. There's the oil and gas fields present day, so you can see the extension of East Siberia here out into the South Kara Sea. Now, I mentioned the two deltas earlier, so you can see they come in here beautifully at the tip points. The Mackenzie Delta has been fairly successful. Exploration in there, there's a lot of gas associated with it, but the pipeline that was going to be built when shale gas was found in the United States, that put a stop to that. The Lena Delta, totally undrilled, 15 kilometers of tertiary sediments, has significant potential. Will it ever get drilled? I don't know. As you can see from the beautiful aerial satellite photograph on the wall, it is one of the most beautiful deltas in the world with all the glacial lakes sitting on top of it. Let's have a look at the geology now. So I said, here's this 5,000 kilometer piece of continental shelf that has no wells on it. Well, we've got some data, because we've got some data from over here in the Barents, and we've got some data from Alaska. And if it's one large, continuous continental plate that's shifted across to open the Canada Basin, we should see the same things. Just like we do in other parts of the world, other big petroleum systems in the world, such as the Middle East, the North Sea. And here's the geology. So we've got, this is what I was working on in Alaska. I was coring the carbonates of the Lisbon limestone and the Shublick source rocks that sit above it. So we've got Permo-Triassic carbonates with Triassic organic rich black shales sitting on top. So that's there. We go over to Svalbard and Barents. We have Permo-Triassic carbonate platform with Triassic source rocks sitting on top. So over this large distance, that could just be coincidence, couldn't it? With 2 points where we've got the geology, we can calibrate it and control it. Well, we can fill in some of the data. Here's the Siberian islands in the East Siberian Sea. Look, what do we find? Permo-Triassic carbonate platform with a major marine flood on top of it. Wrangel Island, we're getting closer to the Chukchi Sea now. Carbonate platform still present, and then an unconformity. Looks as if this, just like you were to drill in the Jurassic of the Middle East and the Triassic of the Middle East, a continuous carbonate platform. Here's some data. This is Prudhoe Bay, one large structure that sits on a rift shoulder that's enhanced by the Foreland bulge from the Brooks Range on this seismic line. Very large structure, world-class source rocks. There's the Triassic, and there is the Cretaceous there. And this is the Prudhoe Field. Everything goes up there, dip into Prudhoe Bay. 19 billion barrels of oil recoverable. It's the largest field in North America. So that's a significant discovery, and that fold belt continues into Russia. Here's Russia. Here's the Barents and the Kara Sea. This is a lovely diagram drawn by somebody I worked with when I was in Russia, Sergei Drachev. He's now with ExxonMobil. He's done a nice diagram of what the South Kara Sea and the Barents looks like. Barents is thick Permo-Triassic and a very thin Jurassic and Cretaceous. The Kara Sea, Triassic rifting with quite a thick Jurassic and Cretaceous. This is how East Siberia works. This line was given to me by some friends in the Russian Geophysical Institute when I was over there working in Tumen. Here's the Triassic rift. Here's the Jurassic. This light blue Jurassic is a world-class source rock. It's actually the equivalent of the Kimmeridge clay. It's the same age, same composition. It's a type 2 kerogen. This sources the major lower Cretaceous delta systems via these clinoforms. This is the prograding lower Cretaceous deltas that come off the East Siberian Shield. All the oil fields sit in these lovely, gentle anticlines here. This is in the oil window. These are oil fields. This is in the oil window. We're going to see the same in the South Kara Sea. This isn't rocket science. This is extension of the same geology into the South Kara Sea until we hit the Novaya Zemlya fault belt. Totally undrilled. Large structures. You can see why I liked it. This was going to be my next big discovery. I love paleogeographies in terms of trying to predict source rocks. These are by Ron Blakey. This is that Permian platform before it moved. This is the carbonate platform. Here, with a bit of luck, where I would predict the extent of these Triassic source rocks, right? These are palinspastically restored back to the Permian, so we have to take them forward to modern day. These are regional. This is just, think of it as the Jurassic of the Arabian Plate. The Jurassic source rocks and the Jurassic carbonates. Here, the Permo-Triassic carbonates and Triassic source rocks. There's not many Triassic source rocks on the planet, is there? We haven't found them. Here's where they've been hiding. They're there. Right, the Jurassic. Well, we know a bit more about the Jurassic. This is closer to home. Now at Imperial, I take field trips into this area here of southern England, an epicontinental Jurassic Sea, the Kimmeridge clay. You've all seen it down in Dorset, I'm sure. This extends into the North Sea, into the Norwegian Greenland Sea, and right round into western Siberia. It's the same rock. It's a large area of anoxia. And we can map where that's going to be. So we're going to have Jurassic source rocks as well up there, and in some places overlying the Triassic source rocks. The last source rocks, I'm not going to talk much about it, is in the Tertiary. There's definitively Eocene source rocks. We can see it in DSDPs. We know there was a major Azola flood. The trouble with the Tertiary is it's not mature. There's only two places that Tertiary source rock is mature: Mackenzie Delta and the Lena Delta. It's the only two places where the burial is sufficient. But they are there, and they are regional, and that's where they would be. It's the only time the Arctic Ocean was probably fully enclosed. Right, let's go into technology. You're going to love this. I know I did when I found it. Vladislav Navin will be remembered in history for coming up with this wonderful idea. He was working, or he's probably still working, for Gazprom. There's actually a movie that goes with this, but I couldn't get hold of it. This is a nuclear-powered drilling machine for the Arctic. I can see you're fascinated already. This is everybody's nightmare. If you take nuclear power, Arctic, oil and gas, spills, I mean, you can see that. Again, we can see the headlines. Now, we can laugh, but he's got one thing right. He has taken the ice out of the picture. Everything's happening on the seabed, and the umbilicals come back to the shore. That's kind of how it's going to have to work. You cannot put structures on the ice. They have to be on the seabed. So all this moving ice and 6 months around of the year is taken out. You can produce annually from something like this. I'm not supporting this. Please don't quote me on this one that I love nuclear-powered drilling machines. That would not go down well. But the thought process is correct. This is the sort of thing that's been done in the lab in Imperial. This is blue sky. This is years away. But Jeff Maitland, a colleague of mine, has got this working on the bench. And it probably will not work downhole for about 100 years. But what he's actually done is he's stuck the refinery in the hole. Don't take any oil to surface. You put the refinery down the hole. And it does. He's got lots of test tubes and bits of Meccano and stuff holding it all together. And it does work. And guess what you get there? Hydrogen. And all the nasties are left in the hole. It's a great piece of blue sky thinking, but it's a long way away. But that would help the Arctic, wouldn't it? Right. The problem with the Arctic, as I said before, is everybody wants a piece of it, and everybody has a different view of it. So everybody looks at it through different types of spectacles. Here's Greenland's Prime Minister. Now, he wants Greenland to be separate from Denmark. It's kind of like the Greenland version of Alex Salmond, right? Except he hasn't found any oil. Here's his new best friend. This is Cairn Energy, who came and spent about $600 million drilling some wells for him off Disco Island. Here's Cairn Energy's headquarters in Edinburgh. Now, these are some of the worst polar bears I've ever seen. I'm sorry. I understand why they're there, but these are rather poor examples. So that you can see, everybody's got a different view of should we be drilling off Greenland for oil and gas. I'm not saying who's right. Right, here's one of my favourite stories, because I was part of the start of this. I call it the Battle of the South Kara Sea. This is how important potential future large oil provinces are to major oil companies. If you're a major oil company, you produce 4 million barrels of oil a day. That has to be replaced or your share price goes south. And the Kara Sea is one of the places you can replace it. And here we are. BBC News, I was delighted. BP has signed a joint venture with Russian energy firm Rosneft. Fantastic. For the Kara Sea. BP are in there. That's everything I was working for. That was on the 14th of January 2011. Oh, but wait a minute. 7 months later, here's Rex Tillerson, Chief Executive Officer of ExxonMobil, and his new best friend. And he's now got the same piece of acreage that BP had picked up. That's very good. He's managed to sell it twice. I wish I could do that with some of my used cars. But wait a minute, it's not finished yet. He says, oh, come on. No, it worked okay earlier. I'm sorry, we're missing a slide. Sorry about that, I apologise. There should have been another slide, because BP's actually got back in. Because there's a picture of Mr. Dudley and his new best friend, Mr. Putin. So he's actually managed to sell the same piece of acreage 3 times. I think that's fantastic. I wish I had that business sense. Here's some of the borders that are still in dispute. One of the most surprising one is the USA and Canada are still in dispute about offshore Beaufort Sea. They have not agreed this border. So that's still for dispute. There's a few have been solved, like this one in the Barents Sea. So there's still a lot of politics as to who owns various pieces of the Arctic. And there's our friends, the Russians. Now, they went down, as you can see, 4,200 meters to the top of the Lomonosov Ridge and planted a titanium flag. Fantastic. They got a big medal for doing this. There's 2 of them. And it wasn't for planting the flag. I think it was for actually getting up and finding the hole in the ice that they went down through. Because remember, this ice is moving, so therefore the hole's moving. So there's a lot of politics involved in this. And the Canadians were not happy and described it as sort of 15th century diplomacy. These are the tribes, the indigenous peoples that live around the Arctic. So 50%, you can see they're spread around the whole of the Arctic region, really, apart from northern Greenland. And they have been involved heavily in North America in the whole process. They have not been involved at all here. There is no consistency to the way this has been regulated. I guess I drew this map about 10 years ago. It was when I thought things would happen in the Arctic. And without going into too much detail, this piece of eastern Siberia, I thought, miles, I don't even have to worry about it. It's way in the future. Well, the future has come a little bit closer. That's the blocks that ExxonMobil and Rosneft have licensed, which I find is a little concerning. I'm not in the oil industry anymore. I can look at this, I think, a lot more objectively. That is licensing way ahead of the technology. So, no problem with the South Kara Sea. I think that's correct. But this area here, licensing it is just a little too soon. So I don't necessarily agree with that. I don't think we have the technology to deal with exploration and production there. I certainly don't have the spill containment technologies in place. So, to summarize, sorry I've run on a little bit longer. Let's see what we can leave you with. I think we'd all agree, vast unexplored areas. That doesn't mean to say there's oil and gas there, but there's a lot of room to go exploring. And the database is weak, but that shouldn't be a problem. As petroleum geologists working in frontiers, this is what we do. We take bits of data, put it together, and try and build a picture of what the subsurface geology looks like. I hope I've shown you that there's real potential for world-class regional source rocks, and that there's passive margins, delta systems, and rift basins that really should work. Some of them will work because they are no more than extensions of working onshore plays. Right, here's the problem. Development, sustainable, whatever sustainable means, will require real partnerships. I haven't seen too many of them yet between governments, industry, and indigenous peoples. It's not there, and there's no consistent approach between Russia, Norway, Greenland, Canada, and the US as to how to approach the Arctic and how to regulate it. So my last question there, and I left this with the 500 Canadian petroleum geologists I was talking to 2 weeks ago, is it all happening too fast? When I was up in the Arctic, you were right in the frontier, but we were using technologies onshore or on islands offshore we knew would work. If you're in 200 meters of water with moving ice, I'm not sure we know how to deal with that yet. So, to do this, the oil industry is going to have to be on its very best behavior. Thank you.
Thank you, Al. Very good. Well, question time. We'll start over in this segment first. Questions?
Have you got microphones?
Are they coming on the way? Oh, no question.
Yes.
Gentleman in the green shirt, then.
Hello, Tony Edwards, architect, very interested in future energy for our homes. Can I ask about, thank you very much for a very clear talk. Can I ask about BP's sort of ethical approach?
Oh, I can't talk for BP now.
Well, your understanding of oil companies' ethical approach to the twin crises, climate change and resource depletion, primarily oil and gas we're talking about. BP's recently had a renewables department until the Gulf disaster, so they know about the issues. I've been reading this book, Burning Question, Mike Berners-Lee and Duncan Grant, who say that fundamentally that we know how much oil and gas is available today, whatever we find in the future in the Arctic. Nevertheless, if we burn more than half, even some people say more than a fifth of it, we will destroy for our great-grandchildren our climate and their resources. What is the ethical approach?
I can only talk for myself. I mean,
Right.
I've been out of
Please
industry.
speak to yourself, for yourself.
I have been out of industry for 5 years. I now teach young, very impressionable and very smart scientists who ask me very good questions about this very subject. I don't have all the answers. I certainly don't have the answers. What I can tell them is we're using a lot of energy. We're hooked in energy on this planet, and I don't know how we unhook ourselves. We will need an alternative to oil and gas and burning coal. And, you know, if we could find a way to get to clean coal, we would go a long way to stop putting CO2 into the atmosphere. We really would. In terms of the near future, and do we need to go to the Arctic? I would say if we could stabilize the Middle East, we wouldn't. But what's the chances of stabilizing the Middle East? It's a mess. People worry about energy security. We hate the lights going off. So for the foreseeable future, we need oil and gas. I'd rather it was gas, because I think it's cleaner, but it's still, you know, there's still emissions associated with shale gas and producing gas naturally from gas reservoirs. It's a real problem we have in front of us. I don't see the solution. We can't even get the governments to agree on how they're going to regulate the Arctic, how they're going to environmentally regulate the companies that are working up there. I mean, you look at it, I'm sure, as much as I do, and you've probably already seen the differences between Russia and North America in terms of the regulatory framework and the requirements for operations in these areas. I think there's a problem there, and you've got to get the Arctic Five sitting around a conference table and sorting this out. And they're not natural bedfellows, are they? The five of them.
Thank you.
Thank you. Right at the very back.
Yes, this is Susan again. Given that your prediction for the exploration is accelerated in the Arctic, what do you think is the possibility of production, seafloor production, being accelerated as well?
Yeah, let me just use the analogy of the North Sea, if I may. When I first joined the industry, the North Sea really had just got going. Oil was equivalent of $2 a barrel. We really didn't know how to produce from offshore, but some smart engineers worked it all out. And it wasn't long before we were going into deeper waters from 40s up to Magnus. When you find it, it's commercial, it's big enough, people find a way. That's what kind of worries me at the moment, is this needs to be done in slow steps, like it was in the North Sea. People went slowly. You think of some of the things that have happened in the oil industry for the last 5 years. I'm not mentioning any names or any wells. But once you get into frontiers, there's a tendency to go beyond your ability to deal with any problems. And that, the further you go out into the Arctic, especially the far Arctic of eastern Siberia, you are getting into that area. You have to do it slowly. You've got to gain people's confidence. Governments, environmental agencies, local peoples, they have to be part of this. And if you just go charging in, license things and start drilling, I think that is not smart. That's my own opinion, but I just don't think it's that smart. You've got to take time to learn, not by making mistakes.
And there's a gentleman right at the back, Al. Yes. Oh, no, right. Gentleman in the front.
Thank you. I'm Alastair. I work at the Royal Botanic Gardens Kew and I'm a botanist. And I visited the Brooks Range in Alaska in 1980.
Not long after I was there.
Not long after you were there. And I do remember I wasn't after oil or gas, I was after plants.
Neither was I, actually. We were just drilling for the geology.
But what was striking at that time, and you must know about this, was that Jimmy Carter had just signed the Native Claims Settlement Act, which sort of divided the whole of Alaska between the industry, the state of Alaska, and the native people.
Yes.
Do you know, and I remember that basically many of the natives had the view that this was merely a money handout to placate them so that the companies could go ahead and do what they liked. Could you tell us what has become more than 30 years after the Native Claims Settlement Act in Alaska? How are the native people there, the Inuit as well as the Athabasca Indians, how are they involved in this exploration of oil and gas?
I haven't followed that as closely as you would probably have liked me to be able to answer this properly. They are still involved. They are part of trying to draft new regulations to allow, would you believe it, shale oil operations on the North Slope for this source rock I was talking about. They have benefited from the revenue input, or the bribe, as some people would call it. There's strange, from what I read in the various books I've picked up on the subject, there is even a division between how the various native tribes are treated in the United States and Canada, across the border there. And I know in Alaska, they tend to vote for oil activities, whereas the same tribe in Canada will vote against it. And one tribe voted against the Mackenzie Valley pipeline for many years, whereas they were taking the money quite happily in Alaska. So yeah, it's complex. It's, whenever there's money involved, you know what happens. But as far as I know in Alaska, they are still involved.
Thank you.
Right, just one more, Nemeth, over this. The clock is ticking.
Yeah, I've got one question for the audience.
Oh, have you? Oh, even better.
Thank you for a great talk, Mark Davis from McKinsey. Do you have a view as to what kind of company or company types will win? Will it be the national oil companies, the Rosnefs, who sort of have the might? Will it be the sort of independents of BP, Shell, Exxon? Or will it be the Kens? Who will have sort of the risk appetite and the technology and the capital to, quote, win?
Oh, I think this is one of the last frontiers for the majors. Don't you? The opportunities to find large oil and gas elsewhere in the world with potentially high rates of return, I mean double-figure rates of return, are getting pretty few and far between. Pretty room around the world for independents and smaller players, and the national oil companies need worry about nothing. But in terms of the majors, the Arctic's very important. And it looks as if Russia are more than happy to enter into partnerships with the majors, as long as there's some quid pro quo in terms of entry into places like the Gulf of Mexico. So I think it's certainly no sign in the Arctic of it being closed off to majors. Let's face it, the technology is going to come from engineers who are sitting within the major oil companies, who have solved major problems in terms of deep water and frontiers elsewhere. So they will be looked at very favourably by most governments. Whether it's Greenland, Russia, it's never an issue in Canada and the United States, and or Norway. So I think this is probably one of the last playgrounds for the majors.
Alice, your question.
Yeah, I've got one question for you. I mean, I'm always interested. Since I've left the industry, my views have changed in the way you go about exploring frontiers and how to do it and how to do it properly. But what do people think here? If I could have a show of hands, how many people are against drilling in the Arctic? Okay, so that's almost 50%. How many people are for it? Good. So it's about half and half. Right, here's the tricky question. How many people think it will happen? Yes. Yeah. I'm afraid history is telling us what's probably going to result here. Okay, well, thank you very much for your attention. Appreciate it.
Let's thank Alice.